Since we sent the parts out in June, I had some of our technicians probably once a week would come up to my office and say, hey, what's going on with that? When's this thing going to fly out?
3.
Because I think there were a lot of doubters. One little slip up is mass disaster.
2.
The lead engineer at NASA really put it on the line and said, I'm going to roll with the technology house and Carbon and CE 221, and made it work.
1. And we have ignition.
The team of engineers assigned to NASA's Project Seeker were trying to design and develop a small, fully automated spacecraft. The catch? They had 1 calendar year to do it.
So we came up with this crazy idea to use additive manufacture. They had heard of the Carbon technology and the CE 221 material.
CE 221 was selected after an extensive materials trade due to its unique mechanical properties.
So extremely rigid, held up to high temperatures and high strength.
The Technology House team received designs directly from the engineers at NASA. From there, TTH fabricated the new designs, allowing NASA to begin testing the designs almost immediately.
And when they're trying to go from design to launch in 1 year, a day is like a month in that development cycle.
In the end, there were about 10 design iterations. The team was even able to execute a full design, test, and evaluation cycle in 1 week.
Ship parts out, get feedback the next day, make changes, and start printing again. It's right there, you're right in the thick of things, and you're moving fast. Personally, I've been on edge on it for a long time. Hey, we know we can print the part, but we didn't know, and they didn't know, any other plastic additive manufacturing components that have been used in spaceflight.
Huddled together in mission control, the NASA team of engineers watched anxiously as the Seeker robot deployed from Cygnus and completed its mission successfully.
It hit the temperatures that they thought it was going to hit. It was at the strength. It was at the mass. When I hear that, I go, okay, that's performance to me. The customer got what they were expecting. All that effort and everything we did back and forth when you said, is it all worth it to do everything? That made it all worth it for us and our team.
Carbon and CE 221 proved fit for space.
If you're going to get any part certified, I think it's going through NASA and putting something on the space station, like that's the ultimate test of a material and a part and a process. With Carbon, you can use engineering grade materials, a great platform with a finish that looks like injection molded parts, and you can get it and run it in production. Pretty insane to see parts you made on this tiny little thing, because it's about the size of a loaf of bread, just flying around in space. So